Okay, guys, this is our last unit. I'm sorry, our last chapter of this unit. So you know what that means. I'm hoping to get a nice review in here and maybe get the test in before Christmas break so we don't come back to it. Okay, so we'll be doing this week and then reviewing next week and then having our chapter unit 3 exam before you leave for the holiday. Okay, so here are the essential questions that we've had so far. We've graphed an absolute value equation. We know how to determine the max or the min of the absolute value function, right? It's a V. It's either a minimum if we open up, or if it opens like this, it's a maximum. We know how to find the vertex, etc. And now we're writing the absolute value equation. We know how to do that from a graph. We just did inequalities. This is what we did. This is our new concept, which is the last concept. How do you graph a linear inequality in two variables? We did that with the shading. Okay, now what we're going to do is graph the solution to a system of inequalities. Okay, we did the linear inequality, we did the absolute value inequality, and now we're moving to a system. Okay, so just a little preview of what all we've learned so far in this unit 3. Okay, and this is the very last thing, as you see. How do you graph the solution of a system of inequalities? Okay, so let's look at 3 different inequalities. Okay, y is less than and we've done these. Okay, we know how to do these. Y is less than the opposite of the absolute value of x minus 1 plus 7. We're going to do that in yellow. In class, we did this. I'm going to have you do this in breakout rooms. Okay, this is just a review of what we did in class this week. So my vertex, I can see this as an absolute value equation. The vertex is at 1, 7, and positive 1, positive 7. Okay, that's here. I'm opening down because it's negative outside of the absolute value. So I'm going to go down 1 over 1 a few times. Lots of times, I think. Might as well get a nice graph of this. Okay, and then the same on this side. Okay, we're opening down. Now, since it says less than, I'm not going to make this a solid line. It's a dashed line, right? I'm not going to be right on this. It's everything less than those y values, everything less. So here's the answer to, this is what we did last week. Okay, so that's a little review, what we did last week. We also, let's see, in orange, I want to graph this line. You can see this is a line, right? There's no absolute value to it. I'm going down to -5 on my y-axis. My slope is -2, down 2 over 1, or up 2 to the left 1. And it's greater than or equal to, so I can make that solid. Okay, and I want everything greater than or equal to that. Let me just check 0, 0. 0 is bigger than or equal to -5. Yes, it is. 0, 0 should be in the shaded part then. And that's kind of what I was thinking with the y coordinates being above this. Okay, so there's the answer to the orange graph, everything to the right of this line. And then we want to do one more. Y is greater than 3x minus 7. So I'm going to go down to -7. Up 3 over 1 is my slope. And it's greater than, so I am going to do a dotted line. It's kind of hard to see the red, isn't it? I should have picked a different color. Everything bigger than that. Again, let me try 0, 0. Is 0 bigger than 0 minus 7? Yes. So 0, 0 should be in the shaded spot. So I'm on this side of the line. Oops, sorry. I went over a little bit. Okay. What we want to do is notice the area that were shaded when I did all three equations. Okay. All three equations. We want to see where those are solutions to all three. Okay, so where I shaded yellow, orange, and red would be the answer. Okay, so I'm going to just try if I can see all those. Oops, had to be with the yellow. It's kind of in between. You see where the yellow hit right here? It's kind of hard to tell. I made a mess of things, but it's in this little diamond area, okay? Any ordered pair in here will be a solution to all three. Okay, you have to find the overlapping shaded parts, okay? So, we can tell whether or not these things are these ordered pairs are points by looking at what we just graphed. That's how you justify graphically, or we could justify it algebraically. 0, 0. I'm thinking that's in there. Graphically, I would say yes. It is in the shaded area of all three graphs. Okay, algebraically, I would have to put 0, 0 in here. Okay, is 0 less than negative 0 minus 1 plus 7? Is 0 less than negative 1 plus 7? Right, because the absolute value of negative 1 is positive 1, and then the opposite of that is negative 1. Is 0 less than 6? Yes. Okay, and then we already did 0 here. Okay, I put 0, 0 in here and got 0 is greater than or equal to negative 5. Yes. 0, 0 in here, 0 greater than negative 7. Yes. Okay, so we checked it with this one. We checked it checked out with the yellow, and it checked out with the red. Okay. Oh, this was the yellow. Sorry. It checked out with the orange and the red. Okay. This one was the yellow. The yellow one was the absolute value one. Okay, so I put 0, 0 in. I put 0 in for X. I put 0 in for Y, and it worked. Try that for 2, 6, 0, negative 7, and 0, negative 5. Justify it algebraically. Justify it graphically. Okay, take a minute and do that, and we'll come right back. Okay, so hopefully you tried that on your own, and these are the results. We did the first one together. The second point is not a solution to the system. Okay, it ended up being on the dotted line of the absolute value inequality. Okay, it wasn't in the shaded region of all three. If it's on the dotted line, it doesn't count as a solution. Okay, we learned that last chapter with solving inequalities. And it's true with systems as well, okay? Here, if I'm checking to see algebraically, is 6 less than, I put 6 in for Y, 2 in for X, 2 minus 1 is 1, absolute value of 1 is 1, the opposite of 1 is negative 1, negative 1 plus 7 is 6. 6 is not less than 6. It's less than or equal to, but it's not less than 6. So that would, right away, that was false. I wouldn't have even had to do these other two. Okay, as soon as it's false for 1, you don't even have to do the other two. The other two do end up being true, I think. 6 is greater than or equal to negative 9, yes, and 6 is greater than negative 1, but it doesn't matter. It was false for the yellow one. 0, negative 7 was not a solution either. Okay, it didn't work out for either of these two. It worked out for the yellow one, okay, for the absolute value graph. You know, negative 7 is less than, what did we put in? 0? Oops, I forgot my little opposite sign. Negative 7 is less than 6. That was fine. But these two were wrong. And the way we can tell that 0, -7 doesn't work graphically, I took off this so that we can see things. This is the white part is what's the actual answer in here. And 0, -7 is way down here. It's not in the shaded area, okay? So no, has to be in the shaded area of all three. You do have to be careful when you graph them that you don't darken it so much that you can't check answers. This one was fine, 0, -5. It was in the shaded region and it ended up being on the line, okay? When I looked at this orange one, -5 greater than or equal to -5 is what I end up checking. And -5 is greater than or equal to -5. So it checked off fine there. It checked off for everything else, okay? But notice the difference. This is saying 6 is less than 6. That's not true. That was false. Here's -5 is greater than or equal to -5. If it's on the line, then that counts as the solution, okay? Wherever it is, 0, -5. Right here, it was on the orange line, and it was in the shaded part of everything else, okay? Anyway, that's why it said to shade lightly, and I ended up darkening it in so hard it was hard to tell. Hopefully you did it a little bit better. Let's look here. These are two different systems, guys, okay? And it's just going over what we were just talking about. Algebraically, if I'm going to check to see if 1, 2 is a solution, and I don't really feel like graphing it, you don't have to. You just put 1 in for X and 2 in for Y and see if that's true. 3 - 4, is that less than 1? Yeah, we're good there. And then we put 1 in for X in the other equation. I'm moving to this one. 1 + 3 × 2, is that greater than 5? 1 + 6 is 7. Yeah, 7 is bigger than 5. So this is a solution, true. I don't have to graph it. I can figure it out algebraically. Let's try -1, 2. I'll put -1 in for X and 2 in for Y and see if I get something less than 1. -3 - 4, yeah. -7 is less than 1. Let's try putting -1 in for X here and 2 in for Y in this equation. See if we get something bigger than 5. -1 + 6 is 5. Is 5 bigger than 5? No. Therefore, this is false. This is not a solution to that system. Graphically, I graphed Y is less than 1/2 X - 1. That's this dotted line, everything under it. X + Y is greater than -1. That's supposed to say greater than or equal to. I forgot the equal to sign there. Greater than or equal to -1. That's everything up here. Okay, so now I don't really have to do any math since I have it graphed. And I just want to see if it's in this doubly shaded region. It's above the line, but below the dotted line. So let's graph 4, -1. That looks good. That's in the region we like. 1, -3. Ooh, nope. 2, -3. Okay, since that's a solid line, yep. -2, +1. I'll go with that. 0, -1. Shoot. It's not, it doesn't solve both, does it? Because it's on a dotted line. Yes, it's on a solid line, but it's also on a dotted line. It points on any part of a dashed line cannot be a solution. So unfortunately, that's a no. Okay, because the 0, -1, even though it was a solution to one of the equations, it was an inequalities, I'm sorry, it wasn't a solution to this one. Okay, does that make sense? All right. Tell whether the given ordered pairs are a solution to the system. All right, so you can graph it, you can do whatever you want, but let's practice this skill. You will have to log back in to get the answers, okay? So you can stop this video and do the problem and then start the next video to find the answers. All right, see you in a couple.